All right. Thursday, June 16th, first hour. Welcome back. Any particular questions about the homework? I didn't run every response that you guys turned in, but I kind of spot checked them, and everybody it looked like everybody was getting it. Um, it, Edgar, was it your homework that you turned in, like the table in single quotes, dot column in single quotes,
Not sure. I can open it up and check.
or was it Kevin? Single quotes on table dot, and then the dot column name were both in like backticks.
Oh, yeah, I think it was me.
Edgar,
I remember now, yeah.
where'd you come up with that?
I did a little bit of Googling. I think it was on oh no, you know what I did? So I opened each table in a different SQL tab just to know what columns I could use.
Mm-hmm.
And when you do inside of what's it called? The program we use, when you do send
Inside Workbench,
to,
yeah.
yeah, you can do right click and then send to a different tab, and then you do a select all. It'll put it in those quotes, and then I just copied it from there.
Oh, okay. Um, yeah. That explains it. Do you mind if I share that?
Yeah, yeah, go ahead.
Let's see. I think I had that tab open. Yeah, here we go. Everybody see that?
Not yet.
You're not sharing.
Not sharing. Okay, well, it would help if I shared. So when Edgar used the 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 GUI function of Workbench, it goes ahead and sticks the fully what do you call that? Fully resolved table dot column name in tick marks, um, so that there's absolutely no confusing the database as to which, like if there's columns that are the same name in two different tables, this automatically um, specifies which table you were talking about. So there you go. Yeah, so I ran perfectly. Okay, so no questions, concerns. All right, we'll keep going with um, the the rest of that presentation from yesterday, which I left off before I started talking about. We were joining two tables, right? Doing a classic inner join. Here we're using the old fashioned where, but we learned how to use a inner join. So we were selecting columns from one table, inner join another table, and then on, and you just list the two fields from those. But sometimes, like in the case of our North Woods, sometimes you have linking tables that you don't necessarily need to display anything from them, and you don't necessarily need to constrain your data based on them. They are just the way that many to many relationship gets resolved in the database. Like course section is one of those tables, and enrollment is one of those tables. So moving on to multi-table queries. Okay, multiple tables. They're basically the same. Same syntax. You just have to you do that join on for however many that you need to link the data together. Same process. And sometimes you have to include an intermediate table to join fields to get what you want to display, even though those fields in that third or whatever, third and high and more table, third or fourth, aren't in the select, and they're not in the where, they're in the join to get the data to match table to table. So we're going to write a query that lists the last names of faculty members that teach during summer 2007. So we've got faculty table, that's where names are. Term is where we're going to get term description, summer 2007. And course section is where we have our faculty ID assigned to a course section of a course. Okay, so we will not display any field except the last name. So this, when you do this, it's always a leap of faith that that what is coming out is what you looked for, because you don't have any of the data next to it. You don't have term description summer 2007 next. You just need the last name, and that happens. So you kind of have to break down these queries to have faith that your results are right. You have to kind of disassemble the query. That's what some software testers do. But anyway, so we're going to select just the last name, just faculty last name from faculty. But we've got three tables here: faculty, course section, and term. Even though F_last is only in the faculty table, but we need those other two for our join. And we're using old school inner join here, where faculty ID equals course section ID, and course section term ID equals term ID. So that's kind of like a cascading, 3-level link up. And term description equals, that's how we get the summer 2007 folks. Am I sharing the PowerPoint correctly, guys?
Yes.
Yeah, cool. All right, so I'll select all of that. Yeah, course section is a linking table. It does not, see, it's not in your only data constraint here is term description equals. Everything else is for the purposes of joining. All right, so I'll copy that, paste it in. I did run into one bad quote. If you're following along with my PowerPoint, I did run into one bad quote that we'll hit today, I think. So there they are. Those are your 3 faculty members that are teaching a course section in summer 2007. So they're the only folks you'll be seeing on campus. There you go. So course section was purely a linking table. All right. Okay, so this time we're going to display, which goes in your select, our faculty last name, course section ID, the term description, which is, fall 2006, whatever, and term status, which is open or closed. For all terms the faculty member teaches that are closed, sort by faculty member last name. So we do have, again, here's that join, but I really want to convert one of these if I don't already have it on the shelf here. I want to convert one of these to the join syntax. Okay, plug that in. Yeah, there's that status showing up like it's a keyword again. Last name, section ID, term description, and status from those 3 tables. And we have we're linking faculty ID from faculty and course section. We're linking term ID from course section and term. And then we have our actual constraints, term.status equals closed. And we are sorting our output by the faculty last name. Okay, no weirdness there. Everything looks right. If I don't get to it, I'm gonna go off script and do it and convert that to the join syntax. Yeah, same thing here. Okay, suppose we want to see the course name for all students and the grades for Sarah Miller. So we're selecting call ID, which is your course, your plain English course name, and the grade, which is over in the enrollment table. So we got call ID, and now we have to, even though we're not displaying columns from 1, 2, 3, 4 tables, they are still in our from clause, or if we were using the join syntax, they would still be, which is all still in the from clause. That from, this, join, another table on, that's still all in your from clause. So even though we're not displaying them, we still need to select them in our from clause because we're going to link those commensurate fields. And this is another point to make is if you get to be in the design phase, it can help using the same column name within different tables. It's so you don't get confused as to what that is, because it is the same attribute. That column is the same. So to call it the same kind of makes it more understandable. But there are some organizations that won't do it that way. They'll make you change, like it's the same thing, but they would make you call it the E_ID in the enrollments table, and the S_ID in students table. Anyway, there's more than one way to do it, but I think it makes it more easy when you use the same column name in different tables if it's the same data element. Okay. So there we're joining all 4 tables. And what's my note to self here? If there are multiple Sarah Millers, we get them all, not a very specific query request. Yeah, this is just you wouldn't necessarily write a query based on name. You would use the student ID. But let's run this, see what we get. Okay, so we're selecting the course name and grade from student, enrollment, course section, and course. Like I said, call ID is in course, and grade is in enrollment. But we need to just select from student because we're limiting our data down to Sarah Miller and linking all that stuff together. So run that, bam. So she was enrolled in MIS 101, got an A, 155 got an A, MIS 301 with a B, and MIS 451 with a B. So there's 4 tables linked together to get all the information you were looking for. Everybody good?
Yes.
Okay. Here we have some Socratic philosophical. What happens if you leave out a join field? It won't error. MySQL doesn't necessarily jump out and tell you that. It comes out in your results. But you get more answers than you expect. If you don't properly join these things, kind of like we saw, you will get for every row in table X, you'll get all the rows in table Y. So that Cartesian product where it's multiplicative. So you get a whole lot more stuff than you thought you would. I think we might be able to try that. Let's see here. Yeah, like for example, if we don't do a join at all, you're basically getting everything times everything. Plug that in. So student ID, student last name, student first name, and student faculty ID, which is their advisor, and faculty last, F last is over in the faculty table. So that's why we had to say student.FID, or it would have erred.
Linear meeting that's been mentioned.
Good morning.
Backlog refinement.
Good morning.
Discussion on WLS with Anton.
I'm hearing.
They've got PCI stand up.
This is Dexter. I'm sorry.
Hey, Dexter, that's all right. Good morning. Yeah, that's better. It's still kind of bleeding over. Is your mic muted?
Oh, I didn't realize it was that sensitive. I'm sorry.
Yeah, Dexter, yeah, there you go. There we go. Everybody muted? Yep. All right. Okay, so yeah, we're selecting student.FID. If you left that off, you'd get an error. Let's prove that. Yeah, down at the bottom, it's pretty small, but you get column F_ID in field list is ambiguous. So you would always have to qualify which F_ID you're talking about. And we want the one from student. So let's run that, but it's going to goof up, right? Because we're not linking the faculty and student table at all. So there you go. You get every combination of everything. So that's a great sign when you get too many rows or nothing. That's a great sign of trouble. All or nothing. So you go back to where we were. Okay. And then redo it, adding the join. Yeah. Let's do it with the real join. From student, join faculty on student dot FID equals. I'm doing this without looking. I hope I get it right. Dot faculty dot F_ID. Does that look right? Did I do my join right?
Yes, I think so.
There you go. Looks right. So again, that's an inner join, which remind me, can you specify inner? Huh? You can, right? Yeah. Which for readability, I think it defaults to an inner join. But for readability's sake, you can put that on there. Okay, so that's multiple table queries, but I wanted to get me a clean slate here, and I wanted to practice. Get like one of these really long ones that's not using join syntax. We don't need one quite that long. Let's see. Let's do this one. Because to me, this syntax is, like I confessed, it's not terribly intuitive for me. Okay, so this is back to where we are joining three tables, with that course section being the linking table that we're not really displaying anything from. No, we're displaying something from it. Anyway, I wanted to convert this to the join syntax. So from faculty, we'll say join course section. And then and that's where we have our faculty and course section. So instead of saying where here, we'll say on, and I got to get rid of term out here or that will barf. Okay, from faculty join course section on faculty ID equals FRSK and now this is where I'm flying without a net, guys. Some of y'all turn this in okay. So now I want to, do I say and join?
I believe you just say join.
Just join here.
Yeah, you
You're
need
gonna
to join
put
term
join and then
join.
the table and then
Yeah,
on
there
again.
we go. There we go. Join course section on where does term go here now, guys? Because
you join term on, and then you'll do the course section ID.
Yeah, so it's like a chain. So you go from
Yeah.
faculty to course section and then term. So you don't have to repeat course section if you don't want to. It'll just like double join it, I guess, or probably wouldn't do anything. But yeah, I think this is where we put term instead of course section.
okay, so dictate to me here, guys. So select, we've got our fields that are going to display from faculty, join course section on faculty FID equaling course section FID. What is the very next line here say?
That should be join term.
Join term. And then on?
On, yeah.
And that's the correct on, right? Do I need?
No,
I don't need
course
T.
section.
You're gonna have to put course section dot term ID equals term dot term ID.
Term on course section dot term ID equals term dot term ID. Does that look right?
Looks good to me.
Yeah, but you got to update that where now. That and needs to be the where, right?
Ah,
Yeah.
correct. Oop. Where, not were. Yeah, from table, join the next table on the column constraint. Join another table on, and then that condition. And then you would, so the next line, if we were joining however many tables, would follow basically that syntax, but linking up however many tables. Is that looking right?
Yep.
Something's wrong. Term doesn't exist.
It might not like
I think it's because you have
capitalized.
it capital. Yeah. So in the join term, you have term is capital.
Ah, sure enough. Case sensitive. Database objects are case sensitive. Bam. There you go. Yeah, I would definitely need to work with this more often for that to become intuitive syntax for me. So there you go. All right. Well done, guys. Good collaborative effort. Thank you. Let's see, where are we at? 9:01. Okay. Any questions on that? To me, it's just practice. After you've seen some examples, you kind of get the concept. You just gotta practice with it. I think I got a little more practice Okay. So these have all been inner joins, which it'll be a little duplicative. In this next presentation, we're going to recover some ground, but we're going to move on to more complex joins. Everybody seeing that okay? Okay, so what we have, but first, just a quick introduction to the concept of a function. So we'll run this query. Which is very simple query. First and last name of all the faculty members, order by last name. Okay, but they come out in 2 columns. So we can concatenate using, this is, I believe, the first MySQL function that we've talked about, but there are many others, just like in Excel, just like in Python, that do things. You send it a parameter and it returns a value just like any other function. So the concat function will take a list of parameters and cram them all together, as opposed to was the plus sign for strings in Python. I want to say it was the ampersand in Excel. So in MySQL, you use a concat function. Other databases use it's called a pipe operator. It's the vertical line. But in MySQL, we use a function, the concat function. So just a quick aside before we move into outer joins and self joins. So I'll copy that, and we'll see that it does, in fact, concatenate that stuff. Okay, hang on, let me troubleshoot this thing. Could that be right? There we go. But you get this ugly, whenever you use a function like that, or if it, a calculated field using math or whatever, you get this really ugly column header. But remember, we can give an alias for any field that we do like that. It could be the database column name is really screwy, and you want to give it something more meaningful before you export it out to CSV or print it out on a report. So this just reinforces how you can add a meaningful column name. By just putting it in quotes out after the some people like to put, underscore instead of a blank. So the concatenate function, we'll go over some more of those sorts of things. But it's pretty much everything you could think to do. There's a SQL function for all, minimum, maximum, average, pulling sections of a string out. We'll go over a few of those before we finish. So there you go. So we're naming a column alias. Okay, now here is another concept that you see a lot, and that is aliasing a table. So in this, we're doing this, very much the same as last time. We're concatenating first and last name and calling that column student. But Here we're joining two tables, but we're using an alias for the table name. So this little S after student and the F after faculty is an alias for that table, so that later in all of those complex join or where clause stuff, instead of using that long column name and typing it over again and kind of flooding the screen, as long as it's readable and it makes sense, you can then use that table alias in your following. You don't have to say student.f_id. You can just say S here in the where clause because you aliased it above. And that's critical here in 4, 5, 10 slides when we join a table to itself and you have a parent-child relationship. You have to have that table aliasing, or it would goof up. Any questions on that? You just put the alias over here. It doesn't have to be a single letter. All right. Okay, so far, we've done an inner join or equijoin, and that brings, if the common value, the linked value, the joined value is the same in both tables. So, for example, we've been doing a lot of students and their advisors. And an inner join, when you link those two relationships between the student table and the faculty table, an inner join will only show you students who have an assigned faculty member, and it will only show you faculty members who have been assigned as an advisor. So it's the union of those two. You don't get any nulls as far as those two are concerned. You won't see any of the students that don't have an assigned faculty member, and you won't see any faculty members that aren't advisors. But sometimes you do want to see those other values, and that's what we'll get into in this section. And of course, instead of doing the old school where, Walker needs to learn how to do inner join, which is what we worked on earlier. Inner join, and you can do the same aliasing in your join clause. So we're aliasing the student table as S and the faculty table as F. And then in our on, we use the alias instead of the full table name. And it's the same execution. Let's run this one. So Blanchard is advisor for 3 people, and then you got Baines, Williams, and Cox. And we can also run it with the join syntax. Same result, same identical result, as you would think. Okay, now, so an outer join, left outer join, right outer join, but there's also left join and right join. I'm not familiar, and I don't cover those. And we will do a full outer join, but you'll see here in a minute that MySQL does that slightly different than other databases. So I'm curious if you guys are doing these at work, what it's like in your database. But this next slide kind of shows you graphically what inner and outer joins do using a Venn diagram. So like this Venn diagram right in the middle is an inner join. So you're getting in the red there represents the intersection of, you know, faculty members and students who have been assigned to each other. But this big white A, say if you were dealing with students first, that would be you would, that would be the list of students who have not been assigned an advisor. And this big empty B part of the bubble, big white empty part of bubble B, is the faculty members, say, is as long as you do students first and faculty second. And that's why the left and right outer join matters, because it is literally the left and right table that is mentioned in that join. So that's an inner join, is that Venn diagram right in the middle. And then you've got left outer joins and right outer joins in the upper right and upper left and upper right hand corner. So we are going to have some examples of those outer joins. Okay, so outer joins can only be done with the join keyword, which is why I need to divorce myself from the where. So here we're selecting, we're going to do a right outer join. So we're selecting student last name, student first name, and faculty last name, same as we did before, right? From student, aliasing it as S. And now we're going to do a right outer join on faculty, right outer join faculty, and we're aliasing it F on, and then the on is the same syntax on S FID or student FID equals F.FID. So this right outer join is going to pull in faculty members who are not advisors, who have not been who have no students that they're advising. Let's copy that. Take a break here in just a minute. So you see there's Sheng, Brown, Cultra, and Boston are faculty members over in the faculty table, which is where F_last came from. But they have not, their FID is not in the student table, but you still see them because we've done a right outer join. So any questions on that so far? We'll do this and then we'll do the right outer join, the left outer join, full outer join, and then a self join when we come back. No questions on this so far? All right, guys.
No, sir.
Okay. Hey, Dexter, when we get back, are you ready to do your Excel project?
No, sir.
No. Okay, well, let's
No, sir.
let's talk about that offline sometime. Otherwise, we'll be back at 9:30.
Yes, sir.
Okay, how we doing, guys? Any questions before we swap this thing to the other side? Okay. Well, let's get back to our show. So, as we were saying, the right and left outer join from these things refer to, well, like in this case, the student table is the table on the left. And in this case, the faculty table is the table on the right. And that's where the right outer join syntax matters. So what we're saying is give me all the rows in the faculty table because we're doing a right join. I also want to know faculty members who aren't assigned as advisors. And that's got a lot of practical applications. So you might very well want to list and you want to see who's not been assigned as an advisor alongside the people that have. And to let me see, to flip this thing and show the students that don't have an advisor, super easy. You just change the right keyword to left. And now we will see, instead of seeing Sheng, Brown, Cultura, and Boston with nothing, now we'll see a couple of students that don't have advisors assigned. And I had to add them in my dummy database. I had to add myself, Donald Walker, and Dwight Eisenhower, the president, the general. So they show up in the left because they don't have a faculty advisor assigned. Okay, so that's left and right outer join, identical syntax to what we've been dealing with. So nothing terribly cosmic there. You just got to add that left outer instead of just plain join. Join defaults to an inner join or an equijoin. Okay. Outer joins. So I got to get rid of my camera. Note that for some two table joins, either the left or right will be the same. Yeah. If there are no null records, it'll look exactly the same. It'll be the one that would normally display all rows anyway, because every row in one table matches one row in the other table. So yeah. If like all students had been assigned and I didn't go in and add those Dwight Eisenhower and Donald Walker, the left outer join would have looked exactly like an inner join because there weren't any students who had not been assigned a faculty advisor. So yeah, won't always be anything cosmic or different. Let's see. Okay, now the full outer join is used to display all rows from both tables. And this would be necessary if the foreign key is not required. Consider in our database the course section table, which lists all sections. And one of the fields in this is a location ID, which is a loc ID, which is the foreign key. And gives the classroom over there in the location table that that section is held in. So suppose we want to see all rows in the course section and location tables. And we know that some of those are offices and will never be used as a classroom. And we also want to see course sections that we have not assigned a location to or a classroom to, so that'll be a missing value. So, so if we do an inner join, we will see only sections that have the location assigned and only locations that have been assigned a classroom. There you go. So no nulls in any of that because it's an inner join. Okay. And I won't bother with the where syntax.
Dr. Walker,
Say it again.
I had a question.
Sure.
Is that what you just did? The inner join, is that considered the subquery?
No, we will get into subqueries in just a moment. I believe in the next presentation. No, these are table joins, inner join, left outer join, right outer join, that are really kind of sort of part of your, well, the inner join can be done in part of your where clause. No, it's just the way to link up tables when you're selecting from multiple tables. We'll get into a subquery here in probably the next hour. Okay. Okay, so now let's add the rooms that have no classes in them. Offices. So the rooms are in the location table, right? So we are going to do a right outer join with the location table over here on the right, because we're trying to find locations that don't have a class assigned to them. We'll grab all of that. Hit that. Okay, so yeah, now we're grabbing all the locations, even the ones that see where we don't have a course section. So we're seeing all of our location codes, all of our buildings and rooms, even ones that have not been assigned a course section. And I believe we're just going to turn right around and make that a left outer join. Now let's add the course sections that have no classroom assigned. Yep. So we will left outer, right outer, left outer, right outer, left outer, right outer. There you go. It's just that simple. You're just reversing the logic. So now we will see all the course sections, but we'll start seeing locations that have not got a course section, which is only one. Course section 14 does not have a location assigned to it. Everybody seeing that?
Yeah.
Okay. Then it gets a little more complicated. This is the one I wanted to talk to you guys about. Full outer join, which is kind of like a combination of a left outer join and a right outer join. But MariaDB does not support that syntax. So I think maybe in Oracle, are any of you guys working in something other than MySQL? Like Seth, you work in Postgres, right?
Yeah.
Have you done any this kind of joining? Do you know if it accepts a full outer join?
I believe it does. I haven't used it. Like I've used some left and right joins for things, but I haven't used like a full outer join for most things.
Okay. Well, just FYI, I think Oracle and maybe Microsoft allow that syntax, but it doesn't in MySQL. But the workaround on the next slide is a union of a left outer join and a right outer join. So it's kind of like doing the same thing.
MySQL has a cross join, right? What does that do?
MySQL has a cross join. Yeah, I don't have any material on it, and I just punched one in. It sounds like it's an automatic Cartesian product. You know, each table times for every value in one table, you get all the values in the other table, so that you get that multiplicative Cartesian join. But I haven't messed with it. I'm on the next break. I might have a chance. I ran one, and it was the exact same returns as an inner join. The results in this little I was looking at, I think, students and faculty advisors, and it came back as the exact syntax, the exact return of of an inner join. So it was the opposite of what I thought it would be. But I'll play with it and we'll see what we get. Cross join. So if we back to the full outer join, if we want all the nulls, everything on both sides, all at once. So this is going to be all locations, all course sections, regardless if they've been assigned or not. We do this great big, you do a left outer join and a right outer join query, and just and put the keyword union in between them, so that it is basically combining that into one big SQL statement. We run that, and I think we see the nulls in both. Yeah, now we get the fact that section 14 has not been assigned a building and room, and we get the fact that building CR room 105 and BUS room 211, all those have not been assigned. So that's the union of both of those, which is what kind of like I thought maybe that's what a cross join is. I'm just curious enough to look into that there, Seth. I'm just curious enough. I just found out about it. I just read that when I was looking up syntax for something, and I just saw it. I don't have any material on it, and I don't know what it might equate to in other databases. But I'll get smarter on that because right now I'm ignorant. So that's a full outer join. You want both sides of the equation, whether or not there are matching records in the other table. Okay. Now the last kind of join that I have material on here is a self join, which you will do frequently if there's like a list of courses. I think we might have this in the database we could play with. A list of courses, and then you have a prerequisite column that says what course you have to take prior to taking that course. But it's the same value, right? It's the same item, just being used in two different columns. So it's kind of like a parent-child relationship. And in our example here, in our Northwoods database, the faculty table has basically an employee supervisor parent-child relationship within the same table. That is something we can use to practice a self join. So you have to join the table to itself, and without getting too excruciatingly out of my depth, what it's doing is creating two copies of that table in memory so that it can then do the SQL as if it were from two separate tables. But that's all done virtually. So, for example, let's see here. Why is that arrow not coming up? There we go. This is the create script for our Northwoods database. Hang on just a sec. Our Northwoods database, and we can see here that chair right here is an FID. So the chair column has to be a value. This constraint on the database, I told you about, you can place constraints when you create a database. This constraint shows you that the chair column has to be populated with values that are in the FID column, so that you can't punch in a chair is like a department chairperson, like a chairman of the MIS department. You can't plug in somebody, you can't give somebody a chair, which is a supervisor, their supervisor's faculty ID, unless it already exists in the table. So there you go. So that's what chair is. It's actually somebody else in the table that's already in the faculty table. And then you have assigned them as somebody else's chairperson. We'll run that however many times it takes to make sense. So let's do a query where we find the first and last name of the chairperson for each faculty member. So we're going to find each faculty member's boss. The chair for each faculty is listed as a foreign key called chair. It's a foreign key, but it's in the same table. So I guess when I have said that a foreign key is a primary key in another table, that's not completely true. Note that we have to use a from containing two of the same table. That's what I was talking about earlier with table aliasing. That's how it creates two copies of the table in memory and lets you refer to them, even though it is the same table. We've got an example of that. Okay. And of course, we got to muddy the water with some concatenation. So we're selecting the first name and last name and aliasing that as faculty, and the first name and last name and aliasing that as chair. But you'll notice here, we've got a C dot first name and an F dot first name. So we go down to our from clause to see what's going on with that. So we are putting the same table, faculty, in our from clause twice, but we're aliasing it differently, so that we really do have an F table and a C table in memory. They're identical columns now, but remember, you can have the same column name across tables. You can reuse column names, but you have to qualify them by saying table.column name. And that's where we are joining on FID equals C chair. Is that making sense? Okay, we'll give that a run. And I want to say there was something goofy about it. If you're cutting and pasting, this may be the one that had the error. Get this to line up better. Okay, so Harold Baines is a chair and John Blanchard is a chair. They're the only chair people out there. And then Baines is the chair, the department chair for Cox, Sheng, and Cultra. So I want to, real quick while I'm doing this, I want to confirm that there's only two values for chair in the faculty table. So let me get a clean. Chair. Yep. Faculty ID 1 and 2 are our only chair people. And we didn't see Boston in that previous. Where'd it go? We didn't see Boston because they don't have a chairperson. They're free floating. And Blanchard and Baines don't have a chairperson, so they don't show up either. There you go. So it seemed like we had another one. And again, this is for any parent-child relationship where you have a value in a table that refers to another column in that same table. Like this chair column, all the way on the right, is only values coming from FID. But I want to say we got a similar situation going on with course. So I'm going off script here, guys, and I want to select start from course prerequisite. Yeah, so we got course ID. And prerequisite as a course ID. That means you got to take. So like for this one, for course number 3, which is systems analysis, you have to take Intro to Information Systems. So let's collaboratively, because I'm sure I can use your help. I want to create a list of courses and their prerequisites. So what I want, and you guys get ready to come off mute and help me out here. I want 2 columns. I want course name, and I want to call that column course. And then I want, next to it, I want a column called prerequisite that's going to be a course name that you have to take before you take that one. Everybody ready to help me?
Yeah.
All right. So from the beginning here, I want to select, and I'm probably going to need to come back and add the alias. So yeah, let's go ahead and do that. I want to select, we're going to call the course copy of the table C, and we'll call the prerequisite copy of the table P. I think I'm going in the right direction. Course name and P dot prerequisite. Did I spell that right?
Look like it.
From, and of course, got to capitalize select, make it look right. From course.
Shouldn't that be
Whoop.
P dot course name up there? Because you want the course name, right? Of the prerequisite?
You are correct. You are correct. Good job, Seth. Because we're just playing course. Go ahead.
What was it? Course name again?
Okay, course name. Do you see the results down here? This is everything in the course table. So, so these are the names of the courses in our little sample database. Now, but then there's a prerequisite column so that, for example, to take, if I can click on here, to take MIS 301, which is course number 3, course ID 3, I have to take course ID 1, which is Intro to Information Systems. And in order to take course ID 6, Programming in Java, I have to take the prerequisite course ID number 2, which is Programming in C++. So what I'm trying to do is produce 2 columns of output. One of them is all the courses, and then the other one is the prerequisite for that course. And I'm doing it off script so that you guys can help me figure it out, and we can rack our brains together. So I'm going to need a course C and a course P, right?
If you want the courses that don't have prerequisites, you're going to have to use a left outer join.
Yeah.
Okay, so course C, left outer join, course P on C dot course ID equals P dot course ID. Is that, am I going the right direction?
You want P dot prerequisite. That's how you're linking the prerequisite to the course name.
Right. But am I, is that not right there? Am I doing? Is that wrong?
I think you want prerequisite, P dot prerequisite, because you're linking the P dot prerequisite to the course ID. Right?
You're right. Yes, you are right. P dot prerequisite. If I double click that, yeah. Is that looking right?
I think that should do what you want it to do.
I think it's backwards.
Yeah, I'm not getting the right output. I got the same thing that you got, but it's not accurate because I compared it to the previous output that you had, and it's not like, for example, Intro to Info Systems doesn't have a prerequisite, but it's saying that systems analysis is the prerequisite.
There you go. It was a right outer join, not a left outer join. There's no prerequisite for Intro to Info Systems or programming in C++, but both of those are prerequisite. Now I've got the column backwards.
No, when you had the left outer join, wouldn't it have made more sense to do C dot prerequisite equals P dot course ID?
Yeah. You got it. C dot yes. Yep.
Yeah, that's it.
Equals P dot course ID. There you go. So the course, but we didn't alias our columns. Let's see. I wanted to call that course, and I wanted to call that prerequisite. Right? And I think we might get into a case statement. You know how null just doesn't look right. That should say none or NA. I think there's a way to substitute. Oh, I know there's a case statement. We'll cover that. I'm sure next week. We won't get to it today. But it would be, I think, more affirmative, rather than, having something blank on a piece of paper for somebody for it to say none, that there is no prerequisite. But I'm not exactly sure how to do that right now when I sit here. But that worked. That is our self join, or a left outer self join, self left outer join. It displays everything like you would want, right? Yeah, because your systems analysis, database management, and web-based systems, yep, I have those as prerequisites. And then we had two that were you needed to have programming in C++. So that works. Parent-child relationship, self-join a table to itself. All right. Any questions on that? Is any else? Oh, Don, modify and run this as a right join. I made a note to myself late last night, and I have that query right here. Why did hang on, let me go back. But that was a good exercise, guys. Thank you very much. Figuring something out together. Let me run this back to our faculty members and chair people. No, come on. Copy. And paste. Here we go. Now, why did I make a note to myself to run this as a right outer join? Or right join, right? Right join, not right outer join. This is, like I said, late at night. I probably should have been in bed. Let me get a new tab. Catted with that. From faculty F, right join faculty C. Yeah, I think I was thinking to myself, well, now we're not seeing people that don't have a chairperson, and the right outer join brings in, or the right join brings in those people. And also, have we talked about how you don't need the word outer, apparently? That's another thing I'm going to have to Google. Right join seems to work as well as right outer join. Right join, right outer join. Yep, same result. Oh, there you go. So I got to look up cross join. Note to self. And see where that might be useful. Okay, so those were table joins. I think next we got subqueries, as a matter of fact. And yeah, those are just practice. I mean, there's no way this stuff becomes intuitive unless you work with it. But that was a good exercise. Okay, so let's talk about subqueries. What is a subquery? Okay, I may be getting ahead of myself, but I think I want to show you why you need a subquery before we talk about what a subquery is. For example, I don't need this anymore. Put that tab away. Don't save. Remember, all of these tabs can be saved as a SQL file. If you wrote a long, complex query, every time you put a tab away, it'll ask you if you want to save it as an SQL file. Don't save. None of these are save worthy. Did I say? Don't save. There we go. Okay. So if I wanted to pull all the rows from the faculty table, where I'm pulling the faculty member who makes more than the average salary of all the faculty members. What would that query look like? And I've got a stab at it here. What do we think? Jeanette, what do you think? Jeanette, are you with us?
Yeah, I am. I'm sorry.
Yeah.
I got up for a second because our lights turn off. So will you repeat the question? Sorry.
Sure.
Sorry.
I want to pull all the faculty members. all the rows or all the columns or just their name or whatever. But I want to know who in the faculty table makes more than the average. What would you think intuitively that query would look like? And I've got my just off the cuff. I'm thinking that's what it would look like. What are you thinking it would look like?
I think that I would even do like how we were doing self joins. Like I would even consider doing that just so I could see them side by side of like the name of the faculty member and their salary.
Okay, so you would select F underscore last and salary. So you're seeing their last name and their salary. How do you limit the rows to only people that make more than the average?
I would make a condition, kind of how you did, like the where salary is greater than average. I would do something like that to make sure that I wasn't including anything that was below.
Right, because that makes intuitive sense, right? Select the people, their name and their salary from the faculty table where salary is greater than the average salary. That makes, when you first think about it, that makes all the sense in the world. And it just does not work that way. That is wrong. And you're like, oh God, why can't you just figure out what I want to do? Why do I have to do something more complicated? But like, for example, let's find out in this example. And here's another of the 60, 70, 90 functions that are available in SQL. Select average salary from faculty. So this is going to give us the mean of $83,615, 38.75 cents per year. So that's the average salary. So we can't do what I had typed in before. Select star from faculty where salary is greater than the average of salary. Even though that kind of makes sense to you, or to me, to someone, you get a invalid use of group function. So the way you fix that is, instead of using a group, what's called a group function, and we'll get into this, instead of using a group function, you have to use a subquery. You have to query the average salary. And instead of in the place of this function call here, you need a subquery, another query, another select column from yada, yada, yada. So that's what we're getting into in this next section. I'm going to give just a little preview, and then we're going to take another break. So a query that would give you the average salary goes in place here. And we always have to put it in parentheses. So a subquery goes in parentheses. So here we would say select average salary from faculty. And we'll go over the rules for these here in just a minute and a little more constraint. But that's why you need a subquery, because SQL doesn't know to go out and do that. It doesn't, even though it looks intuitive and it looks correct, the way that average salary function works, you have to activate it by doing it in a select clause where it goes out and grabs all of the values in the salary table and returns the result in a select clause. So if I run this, we'll now see that we said the median the average salary was 82,000 something or other, and here we see that Baines and Cultra both make more than that, 102,000 and 240,000. Good grief! What is he teaching these people? And if I swap the to see who makes less than average, we see all the rest of them making less than that 82,000 average. So that's why you need a subquery. A subquery is a value or list of values, a single value like this, the average of a column. It's returning either a single value or a list of values that can be used as, you know, as a constraint in a parent query. So that's where we are. So it's, and like I said, here we got that subquery. We got a whole presentation on that one.
Excuse me, Dr. Wallen.
Sir.
Can you put an alias for the average salary so I can see the table better? I kind of got lost in the sauce with that one.
Okay. Can you see an alias for?
Can you, like, where's the average salary in the table?
I calculated it with this select statement.
Yes, sir.
That select statement goes out, pulls every value in the faculty table and averages it and returns that one value. I'll put that in a new tab. So if I want to know the average salary in the faculty table, it could be 2 million rows. That's what I type in. If I want to know the min, same thing. It's going to return a single value. And you kind of got to know, like these are called group functions because they operate on a group of records. They operate on every record. Now I could constrain this further. I could say select minimum salary from faculty where the department is computer science or whatever the case may be. But in this one, I'm taking there's no where clause. I'm taking every salary and I'm running it through this function. So the minimum salary is 28,000. And you could do this by sorting it, but if you got a bunch of rows, it could be a lot easier to, and you might need to know the min and the max because you're not running this interactively. You're actually running it in a script. Oop. Wow, if you don't put anything and you just put it in quotes, it does not complain. Huh, if you just put it in parentheses. That's weird. So the max salary is 240,000, as we saw before. So that query right there, select max salary from faculty or select average salary from faculty, returns a single value. And I can use that single value in a where clause to select where something equals that single value that just came back. And I got a whole presentation on that coming up. Subqueries. Okay. And then we've got practice on that. Okay, guys, let's take a break till 10:30. I'm going to look up cross joins. All right, welcome back for our third hour. Subqueries or nested queries. And these are easy to get confused about or to make them out to be more than they are. But in essence, they're it's you break it down, you decompose what you're doing, and they start to make more sense. So share screen, share. Subqueries or nested queries. Nested or subqueries, same thing. Created when a query is based on the results of another query. Just like we talked about last hour, I had to go out and query the average salary so that I could use it to pull people that made more or less than the average salary. And these things do, a single query in SQL can become very complex pages of code, depending on the complexity of the database and the complexity of the question, just to pull a data set or a specific answer to a question. Okay, so nested queries are really two queries or more, but we're going to deal mainly with the concept of a main query and a subquery. So just like, hang on just a minute. I'm being invaded. Dang. Can y'all hear that? Helicopters?
I can't hear anything.
You couldn't hear helicopters going by? Oh, well.
No.
Anyway, I could barely hear myself think because I live about, I don't know, half a mile from Camp Robinson. And sometimes when they're playing war games, it just gets really loud, guns going off, and we can hear the tornado siren every Wednesday at noon. And I'm also under the flight path of the C-130s out at Jacksonville, Arkansas. So I see C-130s going by my window pretty much every day. So yeah, it's almost like I'm still in the military. Pretty cool. So anyway, you've got a subquery and a main query. The database engine runs the subquery first, kind of like whenever we're dealing with embedded, function calls within mathematical operations. It always works kind of from the inside out, and that's kind of the way these subqueries work. It executes the subquery and then feeds that result to the main query. So the reason you're using these are to specify search conditions for the main query, just like I did with this one. So it's going to run this select average salary from faculty first, and then feed that result, 82.30, whatever it was, feed that up to the where clause in the main query. So this thing in parentheses that I wrote, getting the average salary, is the subquery. And this thing out here that uses it is the main query. Cool. And then that just reminded me when I clicked over here. Seth, are you with me? I see you coming off.
Sorry, yeah.
No, that's fine. Yeah. Okay, so a cross join, back to your question from previous hour. A cross join is just that. It's the Cartesian join. For every instance, if you don't use any kind of a where clause to limit the join, it will grab every row in one table, the left table, and join it with every row in the right table. And you see the result here without any where clause to link student table faculty ID with faculty table faculty ID or anything like that. What we get is a list of all the students paired up with every instructor. So you get Miller and Blanchard, Yamato and Blanchard, and then you get Miller and Baines, Yamato and Baines, and then you get Miller and Cox. So yeah, it's a join of every student last name with every faculty last name, no constraints, no anything. I don't know when you would do that, but there's lots of information out there on it, like at W3 Schools or other tutorial sites. I guess you might want a list of all the possible combinations of something, but it's not something I've ever really taught or dealt with. But that's what a cross join does. All right. Back to subqueries. So that's really all they are. A subquery is really just a single number or a single value or a list of values that are evaluated by the main query as part of its where clause. And we've got a couple of examples of that here. Okay. Here is an example. This retrieves last name and first name of all the students who have the same classification as Amanda Mobley. So we will break this down into its component parts. Okay, so note that the value the subquery retrieves is a single value. Yeah, I've been saying that very clearly, right? A subquery returns a single value or a list of values. Okay, so in this example, if you were to just type in that, which we will do here in just a minute, you would get SO for sophomore. She's a sophomore. So we're pulling all the students from student, they're all the last name and first names, from student, where S class equals SO. For all practical purposes, that's what this is doing. Okay. Rules for nested subqueries. The search field in the main query has to be the same field that you're selecting in the subquery. So, I mean, that'll make sense to you, right? In the main query, we're selecting last name and first name from student where S class equals, and then we've got a subquery. So the subquery has to query something about S class. If we're going to say where S class equals something, it's got to be the same field, right? So that kind of makes intuitive sense. And then there's some more rules. The subquery always goes in parentheses. That can be easy to forget. Don't use an order by clause in your subquery. If the subquery returns multiple rows, a list of items, a list of values, it'll search them all. You don't need to order them. You must have some relational operator in the search condition of the main query, like equals, or like I said, greater than average salary or less than average salary. But very often you'll use in. You use in when you expect this, when you've written the subquery such that it can return more than one value. So you're not using like min or max that's guaranteed to return a single value. If you've written the subquery so that it can return more than one value, you use in, because that's the operator to check if something is in a list of values. And for debugging, you always run the subquery first to make sure that it is returning what you think you've written. Other rules. All tables used in the subquery must be included in the main query, or it would get confused. A subquery is an integral part of the main clause. It's just of the main query. It's just part of the where clause. That's all you're doing is a fancy long way to get a single value or a list of values to use in a where clause. And yeah, there are two types of nested queries that return a single value or multiple values. Generally speaking, if it's going to return a single value, use the equal comparison. And if you've written it to return multiple values, you say in. Because you can't, if you put equal and it returns more than one row, it'll choke, and vice versa. Okay. We'll get to some more examples here in just a minute. So let's write a nested query that displays all the student first and last name that were enrolled in the same course sections as Amanda Mobley. So we got CSEC ID will be the field. So first we need a subquery that retrieves Amanda's course sections. So that'll be the first thing we write. Okay. So this is the subquery. So we're going to get CSEC ID from the enrollment table for Amanda Mobley. So we don't have name. We don't know Amanda's student ID offhand. We just know her name. And we don't have name in the enrollment table. We only have student ID. So that's why we got to kind of do this this little join here. So I will copy that and paste it in. Remember, this is just the subquery. This will just get Amanda Mobley's course sections. So she's enrolled in course section 11 and 12. So that list of values is going to be returned to a parent query or a main query. And sometimes that subquery, depending on the data, it might only return one value. She might have only been enrolled in one, but the way it's written, you would always use the in keyword because it might return more than one. So you always be safe than sorry. Okay, back to the PowerPoint. So that's the subquery. We got 11 and 12. So that makes sense. And then our main query is to get everybody else that's in section 11 and 12. Okay, so I'm going to cut and paste that and glue it in here so that it makes sense. Control V. Let me give myself some more real estate here. Okay, so syntactically, we're not right yet, right? Remember, we got to first of all, we have to put our subquery in parentheses. So I'm going to add that parenthesis. Then I'm going to get that up there. And I'm going to get everything to line up real pretty because that's the way I like it. Okay, so remember, we still have that same, I didn't modify the subquery whatsoever. It's still pulling course sections that Amanda Mobley are enrolled in. But it's going to resolve that. And remember, it was 11 and 12 down here. So it's going to feed a list of values of 11 and 12, which are CSEC ID, back up here into this portion of the where clause, and CSEC ID in the list of values that are returned by this subquery. But we're also doing a little join magic here, joining just like we did in the subquery. We're joining the student and enrollment table on student ID. And we hit that. And we should see a list of first and last names, including Amanda Mobley. Yep, she's in there. So because there's multiple sections, I think we can, and let me see if I'm not going to get ahead of myself here, am I? Yeah. Almost got ahead of myself. The subquery provides all the course section IDs, but it lists duplicates, right? Because there were students who were in both of her sections, so you get that duplicated. Well, distinct suppresses duplicate rows. So we just add that up front, and now we get a list of, they'll only come out one time because it's that distinct keyword suppresses any duplicate rows, no matter how many fields you're selecting from. How we doing there, guys? Perfectly clear? Make sense, Dexter?
Sorry, Dr. Walker. I stepped away for a second.
I'm sorry?
I said, I'm sorry, Dr. Walker. I stepped away for a second.
I still didn't understand, but.
Oh, yes, sir. I understand. I stepped away for a second.
All right. Well, slow me down if I need to go over anything.
Sorry.
Okay. And there, yeah, I went ahead and modified it, but there's our subquery. Just providing a list of values, a list of CSEC IDs that can be evaluated by the main query against CSEC ID. And you could say not in. So let's do that. What if we said not in there? We would get everybody. We would not get Amanda Mobley. We would get everybody that's not enrolled in 11 and 12, which should be including me and Dwight Eisenhower, I think. Oh, I'm not in the enrollment table. I'm not enrolled in anything. There you go. So these are people that are enrolled, but they're not enrolled in the same course sections as Amanda Mobley, Sarah Miller, Brian Umato, Daniel Black, and Ruben Sanchez. Right? Sanchez is both enrolled and not enrolled. He's in both lists. I'd have to think about that for a minute, but I'm not going to slow down and get off schedule. So that's how a subquery works. Yeah, subqueries that return multiple values got to be checked with the in operator. Try this one. Use a nested query to display the course name, which is course ID, and capacity that are taught in a room where the capacity is greater than 40. So the first thing we're going to need is a list of rooms where capacity is greater than 40. And I've got all this ready to go here so we don't. The capacity of all, this will be our subquery, right? So just like I said, what's the average salary in the faculty table? This is kind of the same thing. We got to go compute. You don't hard code this stuff. You put it in a query. So let's select capacity from there, from the location table, and we will get a list of capacities. So we're not asking for the room number or anything else. We're just getting a list of capacities where the capacity is greater than 40. 150, 42, and 55. And then we use that as our search criteria. So I'm just going to cut and paste the main query and stick it in here and make it work. I've got the whole thing, but I don't want to cheat. And capacity in, so we got to go over here, put in an open paren, and then close out our subquery with a close paren, or we get a syntax error. So we're selecting a distinct list of course ID and capacity from course section and location, and then we do the join magic there and capacity in. And then remember, we had a list of 3 capacities, 150, 142, and 155. And those are your courses that utilize that. Apparently, the other one was not, the other capacity was not in the course section table, hadn't been assigned. Okay, so now what I want to do is go off script a little bit, and I want to use join from course instead of joining these in the where clause, old school style. I want to join them using join syntax. So prepare to come off mute and help the old man out. So I'm gonna eventually just have my where clause where capacity is in that. And I'm going to change this part of the where clause to being my join, right? From course section, enter join location on Does that look right?
Yeah, that should work.
Yeah.
There's no, I mean, yeah, there's no red X. So syntactically SQL's okay with it. But yeah, there you go. Same. I'm going to force myself to, I'm going to wean myself off of the where inner join syntax. There we go. Y'all holler if you want to play around or change something, or oh yeah, taking the distinct off. You get more rows when you start getting duplicate rows. That distinct operator is almost always called for. Yeah, and I'd have to go through some serious thinking as to why we're getting duplicate rows like that. If you look at the data as the way SQL pulls it up into virtual tables, just that they only live for the life of the query in memory, you start to see stuff like that. And the distinct keyword very often cures up and gets it to be what you're looking for. Okay. Previous query using inner join. Ha! Got ahead of myself. I forgot I did that. Okay. Nested or subqueries that return multiple values. Yeah, that last one was not the greatest example, because we could have used the capacity greater than 40. So it seems like I came up with a slightly better example of a subquery, but I've kind of already talked about this. This is the similar reason for a subquery that I used with average salary. So this gives me courses that are taught in places that the classroom has more than the average capacity. Okay. You can specify multiple subqueries within a single nested query. Yeah, you can nest these and anywhere you got a where clause. You can add it if it makes sense, if it depending on the nature of your database. You got to use and or to join subqueries. So you could say, like we did before, you know, that CSEC ID, same class or S class or whatever, was the same as Amanda or somebody else. You can use and or in between those subqueries to, just like you can in any other multiple condition in any other programming language. And they get. So we are going to do the names of all students who have the same S class as Amanda, remember, which was SO for sophomore, and have also been enrolled in a course section with her. So we're going to have candidates for 2 subqueries linked with an and keyword. And this is what that looks like. And we're using the where clause to join again everywhere we do this. But let's run this. So we're, yeah, this is your main query out here, right? And then you have 2 subqueries. One returns a single value, Amanda Mobley's S class. So we compare that with an equals sign. But then we've got another subquery that we're using as a multiple condition that can return more than one row. There can be multiple students enrolled in the same sections as her. So if there's any chance, we use the in operator in the list that will be returned. And see, we got CSEC ID in select CSEC ID. We got S class equals select S class. So those always have to line up so that it makes sense, and it does. It makes all the sense in the world when you kind of read it like English and you think of what SQL is doing with these results. So we will copy that, a big old chunk. And of course, herself and Ruben Sanchez are in both sophomore and enrolled in courses with her. And both subqueries are in parentheses in their separate sets of parentheses, all terminated by one semicolon. Okay, a couple more slides. We'll break for the day. One last query. Display student name, last name, grade, and advisor last name. For those that have the same advisor as Daniel Black or have made the same grades as Daniel Black. And by the way, spoiler alert, Blanchard is his advisor and he's only made C's. Okay, so first, we're going to do our subqueries, right? We always write our subqueries first. So we're going to get Daniel Black's grades. So we'll run this. Remember, the enrollment table is where we have their course section and the grade that they got in that course. So we'll run that. And all he got was C. One course. But it could be more. It could be multiple values. So I'm pretty sure we're going to want to use an N. Could be multiple value, just like it says on the slide, Don. Okay, so put this subquery last. And we also need to know who the faculty advisor is for Daniel Black. And remember, we're using Daniel Black because that's what we know his name. We don't know his student ID, offhand. We could have shortened some of this stuff if we just used Daniel Black's actual student ID, but we got a little join stuff here. Doesn't hurt anything. Okay, so we're going to get the FID, faculty ID, for Daniel Black's advisor. Faculty advisor 1, and it's a single row, one Daniel Black, one student. But then we got to combine all that stuff together. So now that you have those two pieces of information, you put them together, and it was an OR, was it not? Yeah, OR. So here's your great big main query up here, and then your two subqueries. This one is for to get the same faculty advisor as Daniel Black, or they've made the same grade. So we're going to be getting anybody whose advisor is Blanchard and anybody who got a C in their courses. But like I said, if you break this down, if you think about these things individually, they make a whole lot more sense. So we're seeing A's and B's here, and that's okay, right? Because we got an OR. So we're saying if their advisor is Blanchard, or they got a C. So we're seeing Baines, but we're not seeing Baines next to anybody's with A's and B's. It's because they got the same grade as Daniel Black, which was C's. Same down here for Cox and Williams and Shang and Brown and Cultura. And whoop, B and A, but we're back to Blanchard. Questions, examples. And we got some time left. We're just going to work on some more exercises if you don't have any questions.
Sir.
Anybody got a challenge query you want to write, or you know what I mean, that we can all work on together, to like something you made up in your head? Like pull all the this for that equals that.
Yes, sir. I know this is our subject, but I was kind of struggling row partition by. I guess that's for another time. I just wanted to put that out there.
It sounded like you said for partition bar.
Yes, sir.
Oh, I'm not familiar. What's that?
Well, I was using it to create a rank to gather information from multiple queries, gather values that are different from the same column, like completed, processing, and failed. You know what I mean?
No, I'm not familiar. I'm pretty sure I don't cover. I know I don't cover that.
Okay.
Partition bar doesn't ring. Anybody else work with that?
No, I'm not familiar.
Okay.
I'd have to see what you're working with, Dexter, and I'd be happy to. I don't know how your client would feel about someone looking at your screen while you're dealing with client data, but I'd like to learn more.
But I did also want to see how can we do a join and put into a temporary table with multiple joins into a temp table.
Yeah, there's a thing called common table expression.
Yes, sir.
That apparently the table only lives in memory as long as for the life of the query itself. I'm vaguely familiar with them. It's not in my basic SQL curriculum.
Yes, sir.
You want me to look into that and cover that while we're doing an example of a CTE?
Yes, sir. I'm struggling with that.
I will. So I did. Okay. I looked up cross join and we figured that out. I'll have an example of a CTE, which again is it's kind of like a temporary table that you construct so that you can use it all within the same query. So it's built in memory, used by the query, and disappears all at the click of a mouse, all within running that same statement. So I'll CTE example. I'll do that.
And Dr. Walker, I was hoping when you get a chance, like the logic between using either a CTE or a temporary table, because I struggle with that too.
Well, a CTE isn't really a table. You're not really creating a table in the database because very often you don't have the right to. Where you might want to use a temporary table that you've constructed just to do some processing, but you don't have rights to that database, and that's why a CTE creates it in memory. It's not really a table, but it looks like one to SQL so that you can do whatever processing you got to do, but without ever having to have database object creation rights.
Okay.
So I think that's what the point of those. But I'll do a little research and we'll do that before we close the books on SQL.
Yes, sir.
Cool. All right. I did want to. I'm not currently sharing. I am screen sharing.
Hey Don.
Yep.
Are we going to cover subqueries in the from and select clauses, or is that something else?
Subqueries in the from clause. I don't think I have anything like that in my materials. I'm trying to think of when you would use a subquery in a from clause. Because subquery pulls, you'd have to query table names and
you can basically write you can write a query that you take from, right? So you write a query in the from statement and then it'll take from that and use it in a select statement on the outside. Or you can use a subquery in the from and select statement. I was just wondering if we go there.
It doesn't ring a bell, and I would need to see the application for that. I mean, like select is a list of columns. That's what comes after select. You can write a subquery that selects column names from like the database description table, that would select column names that maybe where the data type is a certain data type or something like that, and return a list of those columns.
Could you can I share my screen for just a second?
Yeah, let me,
I'll show you.
Sure. Let me but no, hang on, I'm screen sharing. Hang on. Stop share. Let everybody advance. There it is. All participants. You should be good. uh, so INV dot, is that a schema dot table? Is STNO a table?
No, that's a. Sorry, I'm used to having to press space to talk, and it's messing me up. That's a column name. That's a column header, right? From the marketing MFG by vendor. Actually, wait, no, that's from where's invoice or inventory at in here? Oh, that's where it's from, invoice header detail CW right here.
Wow. No, I don't get, no, this is all, I mean, I'm recognizing some of what I'm seeing. But like, it took me a minute to figure out where your table X came from, but it's an alias of that select statement as inside of a from. No, I'm not familiar. And that's beyond my comfort level. Did you write that from scratch?
No, my boss wrote this, but this is like what I have to work with. So,
well, there you go. Yeah, I'd have to. But it would take a while for me to understand what you're even doing there.
All right. Well, I thought I'd ask you.
Yeah, no. But bless your heart. And that's actually an insert statement at heart, right? You're inserting data into a database based on that select statement.
Yeah.
Which, yeah, absolutely. Insert into one table the results that you selected from a complex other query. Nope, we're going to do some, group by having some more exercises and functions and whatnot. But that's about as complex as I get in this course. But I'll look up CTEs, Dexter, and give us an idea of what those might be used for. I did want to show you one other thing, and I'm going to let you loose on a couple of fairly straightforward exercises. Let me share my entire screen. I want to show you a website. And there's an exercise in the classroom that uses this website. But they're all pretty easy. So you should be able to knock them out in short order. But this website is called W3, the numeral 3 schools.com. And it is one of the better resources. This is where I found the cross join example there for you, Seth. This is one of the better resources I have found for both SQL syntax and SQL tutorials and Python. So I wanted to show you. You go to w3schools.com/mysql. I'll put that in the chat real quick here. .mysql. Chat. And it's an interactive tutorial, and it goes over pretty much all of the standard MySQL. It doesn't get into so much stored procedures, but I think there's a section on it that you can get to. But anyway, what I wanted to show you was, if I go to the MySQL home, get rid of this here. If you click on like this website uses a version of the Microsoft Northwind database, which I told you has, like, customers and orders and suppliers and stuff like that. But I want to click on it so that you see the database. When you click on anywhere on this website, anywhere in the MySQL tutorial, it will bring up this little development environment. If the database was a little better, I would think about getting rid of SQL Workbench, but this, you can't do additional tabs and whatnot. This one it doesn't do as good at highlighting things for you. It doesn't give you as good a feedback as Workbench. So, but it is useful. And I've got an exercise in the classroom called W3 Schools. What is it? W3 Schools query. Hang on just a minute. I'll pull it up. And these are very straightforward. Data 22. Assignments. Yeah, W3 Schools single table queries. And there's only 5 of them. They're pretty straightforward. So this is kind of a repeat of what we did last time with SQL number 1. Pretty straightforward, just doing single table queries. But when you click on, on try it, you get this environment. So this select star from customers, if you look over on the right-hand side, it gives you a description of the database. So you've got a customers table, and if you click on it, it gives you all the fields in customers. If you click on categories, it gives you all the columns in the categories table, and so on. And then over here on the left, you have an interactive SQL prompt, just like you do in Workbench. So you could say select a category ID from categories where category ID is greater than, let's select everything. But it's an interactive SQL prompt on a different database. So I kind of want to get you guys over here and looking at this, at least, so that you're not just in Workbench and just working with Northwoods, where category ID is greater than 10, semicolon, run. About 5. There we go. Category ID is 6, 7, and 8. So you get, it doesn't matter what you're working with. It doesn't matter where you click, try it. you get this SQL editor that pops up, and you can type in any legal SQL statement here, and it will give you the results in the bottom, just like Workbench. The challenge, the thing I'm kind of throwing you out there and leaving you out there hanging, is that this this database doesn't have an ERD. So you got to kind of go look at the database to see where you have relationships. But I'm not doing any joins. So in this exercise, so you shouldn't have to worry about any sort of, foreign key, primary key, or any of that kind of thing. So we got that one. And then SQL joins and subqueries. So I'm going to turn you loose and make both of those due. Well, the W3 Schools is already due today, but take a crack at joins and subqueries as well. Like I said, if you get, some done, turn in what you got. I'll take a look. Email me with any questions. I got a couple of questions last time. I hope I got back to you pretty quickly. And text always works. You guys have my cell phone. So let me edit this real quick. Oop, there we go. Joins and subqueries. Make that due today. And if you need more time, shoot me an email. Just keep in touch. We'll make that due today too. Everybody seeing that? W3 Schools, single table queries, and SQL joins and subqueries for the remainder of the day.
Yes, sir.
Okay. All right. Well, Dexter, shoot me an email about that Excel project. Everybody's gone, but you and Cameron, and we can meet offline if necessary. It doesn't have to be between, during our normal class section.
Yes, sir.
So hit me up on when you want to knock that out. Okay, guys.
Yes, sir.
No questions. We'll break for the day, and I'll see you Tuesday morning at 8:30.
All right.
Thank you.
Thank you.
Thank you.
Hey, Dr. Walker.
Sure.
Oh, one of those assignments said 11:59 a.m.
Don't worry about it. I'll edit. Which one did I? Yeah, AM.
Yes, sir.
I'll edit that.
Hey, Doc.
PM. Yes, sir.
Are you able to hear me? Oh, there it is. My little picture was lighting up, so I wasn't sure if I had audio or not. But I was just checking to see, did you get a chance to look at my last SQL assignment?
I did not, but I certainly will.
Okay. There was only two that I felt like I had something wrong with the word clause because I couldn't get rid of null. Well, it was the one that we had to sort all the letter grades, put null at the bottom, kind of such and such. But if I watch, I'll probably the first 30 minutes that I miss, I'll probably see the workout. But though it was that one, there was another one that kind of threw me for a loop with the rest. I felt like I did pretty good on.
Cool. Yeah, that there's a couple of different syntactic techniques, tricks to make nulls come afterward. It's like order by is null and the column name, or it seems like there's another way you can order by the column. You put a negative sign in front. There's a couple of different things, and you're basically tricking the database to do that. But I'll take a look at your stuff and put it in the feedback.
Okay.
Cool.
All right. Well, thanks, and
sure thing.
I'll watch that first 30 minutes. Now they'll kind of help me catch on to what everybody else did, and we'll go from there.
Yeah, I'll get the recording for today posted ASAP.
Yes, sir. Thank you, Doug. Yeah,
all right, well, you too, Chris. We'll see you.
Yes, sir.